So, working on Algebra 2, Unit 2, Topic 1. So, looking at the graphs of y is equal to square root of 5 minus x and y is equal to x plus 1. It says use the graph above to explain why x equals 1 is a solution and why x is equal to negative 4 is an extraneous solution. So, we can see here that the intersection at x is equal to 1 is in both of the graphs. So, what ends up happening is that since there's an intersection, since y equals square root of 5 minus x and y equals x plus 1 intersect at x is equal to 1. Therefore, x equals 1 is a solution. Since the graphs do not intersect at x equals, that's a terrible x equals negative 4, it is not a solution. Now, some of you guys might be wondering, why in the world are they even talking about x is equal to negative 4? So what ends up happening is if you actually try to solve for this, we would say square root of 5 minus x is equal to x plus 1. And to solve this equation arithmetically, or algebraically, we should say, we would square both sides. And if we actually kind of think about how this is organized, so without actually doing any more of the work, what would end up happening here is we would actually get that actual equation built in. So we would actually have, it's going to be slightly off. So we would actually have something that looks like this. And with that done, we're going to get an intersection at x is equal to negative 4. But since it is actually only talking about, in a sense, the first two quadrants, we don't need to worry about that. If I finish this up, 5 minus x is equal to x squared plus 2x plus 1. Bring over the x, bring over the negative 5, I would say. So 0 is equal to x squared plus 3x, and then minus 5, so that's going to be minus 4. So therefore, x is going to be equal to x plus 4 and x minus 1. And x is going to be equal to negative 4, and x is going to be equal to 1. But negative 4 is an extraneous solution if you actually end up plugging that back into the equation. Okay, so it says solve the equation below, indicate which solution, if any, are extraneous. So I'm going to square both sides. So when I square both sides, I get x plus 5 is equal to x squared plus 6x plus 9. Because what we're really doing here is we're doing x plus 3 times x plus 3. And that's the following result. So we get 0 is equal to x squared plus 5x. And then we bring the 5 over, so we would actually get positive 4. We would get x plus 4 and x plus 1 is equal to 0, and x is going to be equal to negative 4 and negative 1. So remember, we're also trying to figure out two numbers that when I multiply to give me 4, but when I add I get 5. So that would be 4 and 1, and those will be my solutions. The reason why I don't have to worry about factoring by grouping is because there is only a 1 in front of that trinomial or quadratic, so we don't need to worry about doing the whole, like breaking them apart into 4 terms. So now we're left with two solutions, but we need to double check to see if one of them is extraneous. So if I do square root of negative 4 plus 5 is equal to negative 4 plus 3, you can probably see right here I get square root of 1 is equal to negative 1, and that is definitely not true. So the negative 4 is, yet again, which is kind of ironic, as the first problem, it is an extraneous solution, while the only real solution here is negative 1. Okay, moving on. Which expression in this is equal to 1? Check all that apply. So we need to remember a couple things. I is equal to, well, technically I squared is equal to negative 1. I to the third is equal to negative I. And then I to the fourth is equal to 1. Now that means I to the 8th is equal to 1. That means I to the 12th is equal to 1. And so we can see here that the 4, the 8, and the 12 are all multiples of 4. So if I want to be equal to 1, I need to find the multiples of 4. So that would be that one and that one. If I was trying to, in a sense, trying to figure out the other values, like let's say I wanted to see which one was equivalent to negative 1, this would be I to the 6th, and then this would be I to the 10th. So there's no known multiple pattern that works with this, but what you can say here is that if it is even and not multiple of 4, then it would be considered to be negative 1 would be your result. Okay, it says circle the correct answer always, sometimes, never in a statement. A complex number is blank a real number, and a complex number is sometimes. Now, if this was the other way around, if it said a real number is a complex number, then that would be always. Because what ends up happening here is I have a real number, right, all real numbers, and then we have another kind of subset there, and these are going to be my imaginary numbers. And then inside all of that are considered to be the complex numbers. Now, why is it sometimes? Well, technically, I could have a spot that is in the imaginary, so then it would not be considered to be real. I could have a spot that is actually in the real numbers, so it could be sometimes. Finishing this problem up. So perform the following operations. So whenever it's a subtraction, you need to make sure that you distribute the negative. So it'd be 7 plus 9i minus 2 plus 3i. Combine like terms, the 9i and the 3i. And we also have the 7 and the negative 2. So that gives us 5 plus 12i is going to be my result. Over here, when I'm dealing with multiplication, right, I have to do my good old foiling. Now, I'm actually going to do this out and take my time with this because this is the one that I always kind of screw up. I also am going to get an I squared, right? Kind of keep in mind that I squared is going to be equal to -1. So there is always going to be some type of standard form, right? That's what they talk about with the A plus BI. So 3 times 5 is 15, 3 times 7 is 21i, minus 20i, and then to finish this up, negative 28i squared. Now combine like terms, the 21i and the negative 20i, and then we also have the negative 28i squared and the 15. Now remember, this is going to give us -1, so that's actually going to change that negative to a plus. So I'm technically adding 28 and 15 together. So if I add those two together, I get 43 plus 1i, or I could just say I. And that should be my result. Okay, this item involves the following statement. The product of two complex numbers is sometimes a real number. Now it says, give an example where the product of two complex numbers is a real number. So the product of two complex numbers, well, 2 and 3 are both considered to be complex numbers, so that would actually be a real number. Give an example where the product of two complex numbers is not a real number. So what I could do is I could take that same 2. I is also a complex number, right? And so 2 times I is going to leave me with 2i, so that is technically not a real number. This is imaginary. Right, so as I talked about before, a complex number could be a number that is both real or imaginary, right? Or a combination of actually both of them. That would be like something like 2 plus I. Both kind of in the real numbers, but then added together with imaginary. Okay, next. So it says one solution to the quadratic equation is x is equal to 3 plus 2i. Now, which statement is true? So if it means that this is a solution, that means that it is also known as a 0. So which means that if I actually place that into the value, we should end up getting 0 for my answer. I also know that if, let's say that x is equal to 4, I can write that as a parenthesis version x minus 4 is equal to 0. So what they're saying here is that this is a factor of x squared minus 6x plus 13. That would be also a good way about approaching it, right? So instead of saying 4, I can also say x minus, and then in a sense, that specific number. But this case, right, we're just using this parentheses 3 plus 2i. Okay, the other solutions to x squared minus 6x plus 13 is equal to 0 is a real number, and that is not the case. So the important thing to remember with a quadratic equation, especially when we have that x squared business, is that we have 3 different options, right? We have 2 real solutions. We have 1 real solution. And then the last one is going to be 2. These are going to be complex solutions. And usually these are the ones that have some type of I in them. So it is some type of real number plus or minus I. Okay, so then the last one says x is equal to 3 minus 2I is the solution to one of those. So to kind of keep this in mind, we might need to do a little bit of work. We also sort of have this understanding of where um, where some of the solutions kind of come from. We can use quadratic formula. We know that there's that excuse me, so that there's this plus and minus version of things. So what I'm going to do here is I'm actually going to solve this out and try and get my second solution. Now I'm guessing that this is going to be true, but I'm going to do the math to kind of go along with confirming that. So x squared plus 6x plus 13 is equal to 0. So I'm going to use one of the methods of actually completing the square. Notice the middle term is actually going to be some type of even number, which actually makes it a little bit easier to solve. I can use quadratic formula. It is going to be time consuming. So I'm going to just write this as x squared minus 6x plus box is equal to negative 13 plus box. So this is how I kind of set up my completing the square business. So I take the negative 6 divided by 2 and then square it, which ends up giving me 9. So if I put 9 on one side, I put 9 on the other. So I end up getting x minus 3 squared is equal to negative 4. Square root both sides, I end up getting x minus 3 is equal to plus or minus. This is going to give me 2I because the negative underneath the radical. And then square root 4 is just 2. Then I'm going to add 3 to both sides, so I end up getting x is equal to 3 plus or minus 2I, confirming that one of my results is the plus version and then also the minus version. Okay, so look at the graph of the quadratic function, x squared plus 5, x plus 5 below. So they say that there are two real solutions to this equation. X squared plus x plus 5 is equal to 0. Is the person correct? Justify your answer. And if we actually just take a look at the graph, does it ever actually hit the x-axis? And in this case, it doesn't. So are there two real solutions? No, there are not two real solutions because the quadratic does not hit the x-axis. Okay, moving on to number 9. So it says solve each quadratic equation below over the set of complex numbers. Now, when they say over the complex set of numbers, that means that you're not just really figuring out the real numbers, but you're also figuring out any imaginary solutions you might possibly have, which also leads to technically what they're called complex numbers. So to start off, I'm going to write this as x minus 2 squared, bring over the 36. And the reason why I'm doing this is because I can quickly just do square root to both sides and get rid of that squared. So I'm going to write down as x minus 2 is equal to plus or minus 6I. Okay, a couple reasons, right? I is underneath the radical. So that will give me, or excuse me, a negative is underneath the radical. So that leaves me with an I. And then square root of 36 is just 6. Bring the 2 over. So I end up getting x is equal to 2 plus or minus 6I. And that would be my solution, right? Two complex solutions. Over here, 4x squared minus 4x is equal to x squared minus 3x and minus 10. Bring the 4x squared over, bring the 4x over as well, so I end up getting negative 3x squared minus x, and then minus, whoops, moved out of the way, minus 10. So what I'm going to get here is I'm going to multiply both of those. Actually, before I do that, I'm actually going to multiply everything by -1 or divide everything by -1 so I don't have so many negatives. Okay, so I'm left with a predicament. So when I brought those values over, that would give me, oh, positive x there. Okay, so that would end up giving me negative there. Okay, that makes a lot more sense. So I'm going to do 3 times 10, which is going to end up giving me 30. And then I want them to add to give me -1. Now there is some other result that is a little screwy with this. I made a mistake somewhere. Or maybe not. I don't know. So looking at this, it doesn't seem like that I can find any specific type of solution that's going to work for this. Right, two numbers that when I multiply, I get 30, but when I add, I get -1. So what I'm going to do, just to double check my work, right, 4x squared. Yep, seems good. 2x, -3x. Okay, so, well, when all else fails, opposite b plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b, which would just be left with 1 plus or minus 1 squared, right? I could actually write that as -1 squared, but that's just going to end up becoming 1 anyway. So minus 4 times a, which is 3, times c, which is 10, all over 2 times a, which is 3. So I'm left with 1 plus or minus the square root of 1 minus 120 over 6, so I end up getting 1 plus or minus square root of -119 over 6, and I think that that is a prime number, so I'm left with 1 plus or minus I square root of 119 over 6 would be my answer. Don't you love when they throw in complicated square root problems into the mix? See if you can try and figure things out. All right, and the last one. So I'm going to bring over the 2, so I'm left with 5x squared minus 9x minus 2 is going to be equal to 0. Two numbers that when I multiply, right, the 5 and the 2, so that gives me -10. Two numbers that when I multiply, I get -10, but when I add, I get -9. So that's going to be -10 and 1. So I'm going to write the following as 5x squared minus 10x plus 1x minus 2. And what I'm doing here is I am breaking apart this -9x into this -10x and the 1x. So -10x and 1x. Then afterwards, I put parentheses around the first group, around the second group, and see if I can take some values out. So I'm going to factor out a 5x. I'm left with x minus 2. And then plus, now a little bit of foreshadowing, right? The x minus 2 should end up becoming in the other parentheses. Since it already is actually x minus 2, I'm just going to take out a 1. So I'm left with x minus 2 is equal to 0. I'm going to write this as 5x plus 1 and x minus 2. So my two solutions are x is equal to 2 and -1/5. Those are my two solutions. And I am finished. If you guys have any questions, please comment down below or comment on my Discord. I do apologize again for my coughing throughout this video, as I'm still trying to hold back a cough. If you guys have any other questions, please feel free to message me on Discord or also on the comments down below. Thanks.